Hey guys, welcome back to the last sample problems of the year. So this is actually a throwback to work you've already done. So there is not any new math in this portion. We are revisiting the neutralization stoichiometry that we did in Unit 1. So recall that for all neutralizations with a soluble salt, so you'll need your solubility tables again, the ionic and net ionic equations, the net ionic equation, is always going to be the same. So this question is just meant to be a refresher for you. You have this in front of you already. We learned this at the beginning of the year. But remember, anything that's aqueous is going to break apart into its ions. Anything that appears on both sides is canceled in the ionic equation, and then we need to reduce whatever our final net ionic is. So for a neutralization between an acid and a hydroxide containing base, we always have a net ionic equation of hydrogen ion plus hydroxide ion forms a water. So putting this into action here, I know that you guys did not love having to go back and forth between the molecular and the net ionic equations. And this part, a lot of you lost marks on. So I've used some simple color coding here to help you out with that. So the molecular equation is green. We are given information about the molecular equation and we're asked to find something in the molecular equation. But remember that not all of these species are actually reacting. So the actual reaction occurs only in the net ionic equation, which is between the hydrogen and the hydroxide ions. So it is your job when solving to convert from your molecular equation to your net ionic and then back. And so anything that comes from the net ionic equation is pink. Anything that comes from the molecular equation is green in your stoich, just so you know where I got all of these values from. So given in the question, we are told the volume of sodium hydroxide and the concentration that we have. So right away I've gone and used N equals CV to figure out how many moles of sodium hydroxide I have. I can't do anything with either of these values. I'm given a volume of hydrochloric acid. I don't know the concentration. That is what I am asked to find. So it's a soluble salt, so I have a known net equation. So it's going to be a hydrogen ion plus a hydroxide ion is going to form liquid water. So if I'm starting with the value I found here, which is 0.006 moles of sodium hydroxide, remember that this is not all reacting. That sodium is not contributing here. So I need to isolate to the net ionic equation. So that's what this first step is. So this is the value that I solved for from my molecular equation. The only piece of that value that's reacting is the hydroxide ion. So for every one sodium hydroxide, one hydroxide ion is released. So this comes from the relationship here. For every one of these in this formula, there's one hydroxide ion. Now I'm looking at the ratio of hydroxide to hydrogen in my net equation, which is where this 1-to-1 comes from. And then the same as at the initial, I have to get this back from my net ionic equation into my molecular equation. So here, I know that in every one HCl, there's one hydrogen ion. So that's where all these numbers, or sorry, these are not numbers, where all of these values come from. And then 0.006 moles of hydrochloric acid. And again, all of this stoich is necessary. If you go straight from here to here and only use the green parts, remember that you're actually missing 2 steps to your stoich, so you will lose marks. I can then use C equals N over V to solve for my concentration. So you have done all of this before. Question 3 says, what volume of a 0.25 molar solution of carbonic acid is needed to neutralize 30 grams of barium hydroxide? So again, it's really important that we're using our solubility charts here, because when I look at this, I see that it forms an insoluble salt. So barium carbonate is insoluble. What that means is I can just do regular stoic because this is not going to break down into ions that I can cancel. Remember, I can only cancel aqueous things, and I have a solid and a liquid. So that means that I am not going to be able to cancel anything from this side. So yay you, if you solve for that, that means it's just a regular stoichiometry problem. You guys have done stoic a ton. I'm not going to go over how to solve that, but you have it in front of you. I just wanted to make sure to explain why it is that here we don't have a net ionic equation. It's because there is no net ionic equation because there's no ions to cancel with an insoluble salt. Okay? So our last question, oh, that's wrong. Our last question here is about a titration. So a titration is literally just a lab in which you neutralize an acid and a base. So you'll have a known concentration of one of them. It's usually sodium hydroxide that's known, that's in a big glass tube. We would have done this right there. I'm sorry, guys. And that's going to drop her into a beaker of an acid that has a known volume but not a known concentration. So by mixing these things together, you can measure how much base and how much acid were used to exactly neutralize. So what I've done first is solved to figure out what the volume of each was. Okay, so the volume of each in milliliters, which I got literally just from subtracting the final minus the initial, same way we always get a change. I then wrote my molecular equation. Because sodium chloride is soluble, I know that my net ionic equation is going to be hydroxide and hydrogen combined to form water at a 1:1:1 ratio. Okay. When I am looking at my actual solving here, again, pink represents things that come from the net ionic, green represents things that come from the molecular. And this is the same logic that we used in the previous question where I'm asked to find things about the molecular equation, given information about the molecular equation, but the actual reaction is occurring in the net ionic equation, which is why these pink pieces have to be here. Remember, it's tedious, but chemistry is about proof. You have to provide proof, and so that's why this is essential. So the first thing I did was figure out how many moles of sodium hydroxide were used. I was given information in the start of the question and told that it's a 0.1 molar concentration. And I just figured out from reading my table here that I used 0.01383 liters of it. So because I have a C and a V value, I can find my moles. The first part of this question requires me to convert from moles of sodium hydroxide to moles of hydrochloric acid. I'm asked to do two things here. The first thing I'm asked to do is figure out the concentration of the hydrochloric acid. And then secondly, I'm asked to figure out how much hydrochloric acid in grams was put into the original 100 milliliter sample. So I can do this because the concentration of hydrochloric acid that I titrated, that I used experimentally, is going to be the same as the one in the beaker that I poured it out of. So for that reason, once I find the concentration of the sample, I've also found the concentration of my original 100 milliliters. So for A, I first find the number of moles of hydrochloric acid, and then I'm just using C equals N over V. The volume came from my table up here. The moles came from my stoichiometry here to figure out the concentration of that part of the problem. Now, there's 3 significant figures for this part of the question because the only values that I used, that's wrong. It's wrong because this is 2 sig figs. And I did use this in my initial value, so this should be 2 sig figs. Please make that change on your printed copies because I've already scanned them. So that means that this is going to be 0.12 molar. It doesn't change anything else, it'll just change the final answer here. So that should be 2 sig figs. So to solve for part B, I now need to use my information from part A. So I've just determined the concentration of the hydrochloric acid. Remember, the concentration that I used to titrate is the same as the concentration of the beaker that I poured that portion that I used out of. So I know that my original 100 ml sample is going to have the same concentration. So because I'm given a volume and I'm given the concentration that I just found, and remember you never use your sig figs in future math, I can find the number of moles needed. From there, all I'm looking at is grams. So I have my molar mass over here, convert that into grams. Now there's only one sig fig here because this volume measurement, which is only used in part B, has only one sig fig. So for that reason, my final answer is going to be that the concentration of hydrochloric acid is 0.12 molar, and you will need 0.4 grams of hydrochloric acid to make a 100 ml sample at this concentration. A couple of you guys have messaged asking about the answer key. I don't have it at my house yet. I think it should be either in my desk drawer or in the cupboard underneath. It's that big red spiral notebook. I want you guys to treat that like it's a sweet, precious baby because I only have one of it. And remember that somebody dropped it last year, so the pages are a little out of order, but you are welcome to have access to that for answer keys because I don't have them here, unfortunately. The rest of the semester, there's only like a week left. Isn't that crazy? A week and a bit. That's going to run as a self-study unit for electrochemistry. You do not have a test for electrochemistry. You do have a test on the second piece of acids and bases, so everything from the last week and a half, and you will have that next Tuesday, and that's your final assessment in class. Then you will have that electrochem self-study booklet. You'll get it later this week. You're going to work on that and exam review until it is time for the exam. Bye, guys.